The T-carrier system, a fundamental part of the series of data multiplexing carrier systems, paved the way for digital transmission of multiplexed phone calls. Developed by AT&T at Bell Laboratories, the system made its debut in 1962 with the T1 variant, enabling the simultaneous transmission of up to 24 phone calls over a single copper wire line. The subsequent iterations like T2 and T3 extended the capabilities by offering higher data rates and more channels. T-carrier systems are designed to carry multiple time-division multiplex telecommunications channels over a single 4-wire transmission circuit, making it a crucial component for trunking between switching centers in telephone networks. Utilizing twisted pair copper wires, the system efficiently transmits and receives signals while employing signal repeaters for extended distances. Before the digital revolution, carrier wave systems relied on frequency division multiplexing, handling analog signals for each call. The introduction of the T1 system integrated digital carrier signals like Digital Signal 1, DS1, to revolutionize communication efficiency. The T1 format, hosting 24 pulse code modulated channels encoded in 64 kbps streams, became a cornerstone for data transmission. Subsequently, T2 and T3 channels expanded the capacity by multiplexing multiple T1 channels. The evolution of the system owes much to the inventive use of pulse code modulation, allowing optimal synchronization and data transmission rates. The decision-making process behind the framing format and channel allocation reflected the meticulous planning and foresight of the engineers at AT&T Bell Laboratories, ensuring the system's flexibility and adaptability over time. In the 1970s, Bell Labs unveiled upgraded systems like T1C, capable of carrying 3 megabits per second through balanced pair cables, and T2, transmitting 6.312 megabits per second, requiring a unique low-capacitance cable with foam insulation, primarily used for picture phone. T4 and T5 utilized coaxial cables reminiscent of the old L carriers from AT&T long lines. High-rate modems were incorporated into TD microwave radio relay systems to enable the transmission of DS1 signals in a segment of their FM spectrum unsuitable for voice service, later supporting DS3 and DS4 signals. RLH Industries, Incarn and other companies introduced T1 over optical fiber in the 1980s, leading to the development of multiplexed T1 transmission methods. Digital signal cross-connect involves the interconnection of DS1 signals at central office locations through a common metallic cross-connect known as a DSX1. T1 spans, consisting of conditioned cable pairs carrying up to plus 130 volts of DC power, are deployed for transmitting DS1 signals over metallic outside plant cables. T1 copper spans are gradually being replaced by optical transport systems, although if copper spans are used, T1 is usually transported via an HDSL encoded copper line. HDSL technology, especially HDSL2, can transmit a complete 1.544 megabits per second T1 over a single copper wire pair up to around 12,000 feet, with fewer repeaters compared to conventional T1 spans. DS3 signals are primarily employed within buildings for interconnections or as an intermediate step before multiplexing onto a SONET circuit, as T3 circuits have limited range between repeaters. Bit robbing is a method where the 8th bit of T1 dia0 channels is overwritten during 2 of the 12 frames in a T1 superframe, restricting the dia0 channel's rate to 56 kbps to indicate circuit signaling states. This method is used in digital data services like DDS, but has declined due to signaling system No7 SS7. DS1 lines are priced based on the local loop, which is the cost to transport signals from the end user's central office to the carrier's point of presence, and the port representing access to the telephone network or the internet. Carriers price DS1 lines differently, with components like loop costs based on geography, faring more costs for longer distances between central offices and points of presence. Some carriers offer national pricing for DS1 lines, charging the same rate across all geographies serviced, marking a shift due to competition and product commoditization in the T-carrier market. Voice DS1 lines have a similar pricing structure, with the addition of long-distance usage charges per minutes used on top of loop costs.